We're still doing the first part of our unit on symmetry, which is to understand the 4 types of rigid motions in the plane. Now, we've learned about 3 of them already. We've learned about rotation, we've learned about reflection, we've learned about translation, and here I'm going to tell you about the 4th type. That 4th type is called glide reflection. Now, you must use that entire phrase, because if you would simply use the word glide by itself, well, that would be a synonym for translation, and that's not what we're talking about here. Now, here's what I'm going to do. I'm going to state the definition. However, I'm almost certain your reaction will be to say, I don't understand what those words mean, so to explain it, I will then immediately do an example. Anyway, here is the definition. A glide reflection is a motion obtained by translation, followed by reflection, where the axis of reflection is parallel to the vector of the translation. All right, let's see an example. Well, here we're looking at a very simple printed uppercase F, and it's sitting on a grid so that we can do things very carefully. Now, I've given you the kind of information you need to specify a glide reflection. That is to say, I've given you a vector, an arrow at the top. As you can see, this vector is 6 units long, where a unit is a side length of a square in the grid. It's going directly to the right. I've also given you a second piece of information which you will need, and that is a certain horizontal line, which will be an axis for a reflection. Now notice that these 2 pieces of information that I've given you, the vector and the axis, are parallel. Okay, that's part of the definition of glide reflection. It's a motion that involves a parallel vector and axis. Now, what are we supposed to do? Well, we're supposed to take the points of this letter F and apply this motion called a glide reflection, and we want to see what we get. So I'm going to use these red dots up here just to help me to illustrate. I want you to consider, first of all, the point which I'm indicating at top left, the top left on the letter F. Now, we're going to translate and then reflect. In the translation step, we're going to follow the instructions that are implicit in that vector, and that is to say, we're going to move to the right, strictly to the right, by 6 units. So 1, 2, 3, 4, 5, 6. Now, we don't stop there. That's not the point that we want. We want to keep going. We want to reflect that across the horizontal axis that's shown. So let's move downward. 1, 2, 3, 4, 5, 6. We've now hit the axis, and since we want to do a reflection, we go another 6. 1, 2, 3, 4, 5, 6. And that's the image of that top left point of the letter F. Okay, let's see what happens if we apply the same glide reflection to the point that's at bottom left. Okay, again, we go 1, 2, 3, 4, 5, 6 steps to the right. Now we reflect, and this time, since we're rather close to the axis, we don't go very far. We go to the axis and then the same distance, 1 unit below. All right? So at this point, we actually know what has happened to the vertical line that makes up the letter F. It has to go over to a vertical line connecting these 2 red dots that I've shown. So let me take a moment and draw that. All right, and there I've done it. Now let's consider yet another point on that capital letter F. Let's take the top right point. And again, let's do the translation and reflection. So I go 1, 2, 3, 4, 5, 6 units to the right. And now I reflect. Well, I go down 1, 2, 3, 4, 5, 6 units till I hit the axis, and then another 6. 1, 2, 3, 4, 5, 6. And so that's where the top right point has moved. Now, if we do this systematically to every point on that letter F, let me show you what we will get. There it is. Okay, let me remove those red dots now. Those were just to help us to see what we were doing. Okay? And so there's the result of applying the indicated glide reflection to that letter F. It takes the letter F that we started with and gives us one that's further to the right, below that axis, and apparently upside down. And here's a reminder of what we just did. Again, I'm showing you a printed letter F, I'm showing you the vector, I'm showing you the axis, and I'm showing you the result of applying this glide reflection. That is to say, applying first the translation and then the reflection. Notice that we don't stop after the translation and show the result that we get. We think of this as a single motion. It begins with that printed letter F at top left, and after we apply it, we come up with the upside down letter F over at the right. Again, what we've done is we've applied a glide reflection, and as we now see, it's a motion obtained by translation, followed by reflection, where the axis of reflection is parallel to the vector of the translation. And here's one more example. Now, this is what I really think of. If you say the phrase glide reflection to me, almost instantly this is the example that will come to mind because it's such a beautifully simple example that we've all seen. This is a series of footprints in snow or in mud. And one can think of this series of footprints as obtained from a single footprint by applying a certain glide reflection repeatedly. Let's think about the one that I'm now circling, the one at top left. That is a left footprint, apparently. And as this person is walking along and swinging their legs, well, the next foot that they put down after the left foot is actually their right foot. And it's not directly in front of the left. In fact, it's a little bit offset like this. And as you can see, well, that's really the same as if we had taken this left footprint and translated it by a certain vector, which I'm now drawing very crudely, and then reflected across a certain axis that's implicit here. And I will draw this, of course, very badly, but that axis is somewhere around here. Okay, so the result of taking that initial footprint and applying this glide reflection will give you this other footprint. If the initial one was a left footprint, then the new one is a right footprint. Now we can do the same thing again. We can take this same vector, apply it to this right footprint, and then reflect, and we'll get this new left footprint. You see, the result of applying this glide reflection twice is really to give us just the same thing as if we had applied a translation, but not translation by that shorter vector. It's actually translation by something twice as long.